All right, so let's talk about even and odd functions. So we've talked about the different types of functions, what makes a function. We talked about increasing, decreasing, and constant functions, relative maximum, relative minimum functions. Now let's look at even and odd functions. An even function, okay, it says the function f is an even function if f of negative x is equal to f of x for all x in the domain of f, meaning the right side of the equation of an even function does not change if x is replaced with negative x. An odd function says every term on the right side of the equation of an odd function changes sign if x is replaced with negative x. All right, so let's do some examples. We have here f of x is equal to x cubed minus 5x. All right. So how do I determine, or how do we determine if this is an even function or odd function? Number one, what we need to do first is replace x with negative x. Replace x with negative x. Okay, so that's what we're going to do. We have f of negative x, and we're going to plug it into this formula here. So we're saying negative x cubed minus 5 times negative x. That's all we're doing, replacing x with negative x. And then let's simplify. The quantity of negative x cubed, that means multiply negative x 3 times. Negative x times negative x is positive x squared, and then positive x squared times negative x gives us negative x cubed. And then we have negative 5 times negative x. That gives us positive 5x. Now, it says if this is an even function, the right side of the equation does not change. But if it's an odd function, the right side of the equation changes sign. So here's the original question. X cubed minus 5x. The x cubed is positive, the 5x is negative. So when we replaced x with negative x, the x cubed became negative and then the 5x became positive. So the sign changed. Okay, the signs change. Therefore, we have an odd function. X cubed, positive x cubed went to negative x cubed. The negative 5x went to a positive 5x. It's an odd function. B, we have here h of x is equal to 4x to the fourth minus x to the eighth power. So we're going to replace x with negative x. So we have here 4 times negative x to the fourth minus negative x to the eighth. Okay, so we have 4 times the quantity of negative x to the fourth power. Whenever we multiply negative x 4 times, that means this is going to be a positive x. So that's going to be x times 4, which is 4x. And then we have the quantity of negative 8, excuse me, the quantity of negative x raised to the eighth power. That would give us positive x times the minus. That will give us minus 8. Excuse me, I forgot the 4 here. And then we have x to the eighth power. So when we replace x with negative x, did our right side change? No, it did not. So this is what we would call an even function. Okay. And then C, we have g of x is equal to x to the sixth power minus 2x. We're going to replace x with negative x. So we're saying we have here negative x to the sixth minus 2 times negative x. Remember when we talk about the number of odd numbers, um, whenever you have a base that's a negative number and then it's raised to an odd or even power, if the power is even, then our answer is going to be positive. If the power is negative, then our answer is going to be, excuse me, if our power is odd, our answer will be negative. Here we have the quantity of negative x to the sixth power. Our base is negative, but it's raised to an even power, so this is going to give us positive x to the sixth power. And then we have negative 2 times negative x. That gives us positive 2x. Now, as I look at this, nothing, the right side did not stay the same, so it's not even. And the right side, the functions didn't, the signs didn't change, so that's not an odd function, so we would say neither. There's nothing that we can do there. So we're going to come back with this concept again, talking about what's an odd function, even function. Now you can definitely just kind of quickly um, look to see what these equations look like when it says odd or even function. So let's look at the first one here. We have x cubed minus 5x. And I want to see what this looks like if we're able to see it, but we have a graph, this polynomial equation. Okay, so nothing really happens, and we, like I said, we'll talk about with respect to the x-axis, y-axis, and all of that stuff. Um, the next one, just quickly, we have 4x to the fourth minus x to the eighth, and when we graph it, if we can see it, if you notice, if you cut at the y-axis, there's a symmetry. So that means that these 2 points here that I'm pointing to at the top, the highest points, there, if we fold on the y-axis, those 2 points will touch. Okay, so we'll talk about this in a few examples later. But just so that you can get a visual, what does it mean by odd function? What does it mean by even function? All right, so the last example on this page here, we did something like this before. What will be the domain? We're going to quickly go through this here. What will be the domain of this function? Go from left to right, the x-axis. It will be from negative infinity to positive infinity. What will be the range? Where do you see activity beginning on the y-axis at what number? 1 all the way up to, not just 1, but negative 1 up to positive infinity. X-intercepts. Yes, we do have them. We have 2. Here's the first one at 2, 0. Here's the second one at 4, 0. We have a y-intercept. Here's our y-intercept. I'm highlighting that, which is at 0, 8. All right, so E, F, and G is asking Where does it increase, decrease, or where is it constant? So let's go from left to right. Okay. Starting on going from left to right, I have negative infinity, and notice that this is constant. And we're looking not on the y-axis but the x. So negative infinity, and we go to here at 0 because there's a change that's getting ready to take place. So it's constant. So we say negative infinity, comma, 0. Then it changes at 0. So then what's going to take place? From 0 to, what is this? 1, 2, 3. This is where it decreases. So we would say 0, comma 3. And then from 3 to positive infinity, it increases. And remember, we're looking at the x values and we're writing the interval notation. Next, it says the number at which f has a relative minimum. And then the relative minimum of f would be what? So what is the smallest possible number? Smallest possible value here. So we have what? This is 3, negative 1. So remember I showed you how to write this out. We would say f, the function f has a relative minimum of, what would that be? Negative 1 when x is equal to 3. So it says here the number at which f has a relative minimum, which will be 3. The relative minimum of this f is negative 1. Then it says find f of negative 5. This is our x value. Here is negative 5. Then we have a point right here. This is f of 5. And then y would be, what is this? 1, 2, 3, 4, 5, 6, 7, 8. So we would say 8. And then for k, the value of x for which f of x is equal to 3. This is your y value. What is x? Okay. So your y value of 3, here's on the y-axis, 1, 2, 3, I want to find. We have a spot here. Here's a point, 1, 3. And then here we have another one. That's 1, 2, 3, 4, 5. So for k, we would say 1 and 5. And then it says if f is f, the function f, even, odd, or neither. Now we haven't gotten into I showed you a picture of it, but the next video we're definitely going to talk about what makes a value even, odd, even or odd. So at this moment right now, we would just say neither. There we go.